Well, hello there. If this is question 9.3. If somebody wants to solve that question using the work energy theorem, let's solve it here for you all. Let's do it here at the bottom. And it's the same question 9.3, question 9.3, but just using the law, the work energy theorem. So in this case, we're doing the work energy theorem. So if you're going to do the work energy theorem, we're starting with work done by the net force is equal to change in kinetic energy. Now here is the free body diagram on both blocks. Because we're working with the network, we need to know the work done by all the forces, because that will be the addition of the work done by all the forces on both blocks. Okay, now in block M1, the work done by normal is equal to 0 because the angle is 90 degrees, and the work done by gravitational force in this block is also equal to 0 because the angle is also 90 degrees. So we have now left the tension 1, the frictional force, the gravitational force of the second block, and the tension of the second block. So if we substitute here the addition of the work done by each of them, done by friction, plus the work done by T1, plus the work done by T2, plus the work done by the gravitational force 2. All this one is equal to change in kinetic energy. So we go furthermore now here, and we substitute the formula for this specific work done for each of them. Friction multiplied by the displacement multiplied by the cosine of 180 degrees plus T1 displacement cosine of 0 degree plus T2 displacement cosine of 180 degree plus mg displacement cosine of 0 degree, and this is equal to change in kinetic energy. This one is M2, this one here is for M1. Okay, so here is what we have. Now we said before, we go here, cosine of 0 degree is equal to 1, cosine of 180 degrees is equal to minus 1. These ones are common factors. This is common factor, this is common factor, therefore this and this will cancel each other. So what we have left after they cancel each other? We have friction multiplied by the displacement cosine of 180 degree. We have the work done by gravitational force on block 2, which is m2g displacement cosine of 0 degree, and this is equal to half mass total, because both objects are going to change in kinetic energy. So this is the total mass, final speed square minus half total mass initial speed square. But what happened, guys? We don't have friction. We have to calculate friction. Frictional force is equal to kinetic coefficient of friction multiplied by normal. We do not have the normal force. So how do we calculate normal? We apply Newton's law in the y-axis. We come here, normal is in the y-axis, so we have to work in that specific axis. There are only two forces acting in that specific axis. We can say that the net force is equal to 0. We have normal minus gravitational force is equal to 0. Normal is equal to gravitational force, which in actual fact will be mg. We're going to substitute this one in the normal and furthermore normal into the equation. So from here we have that the kinetic frictional force is kinetic coefficient of friction multiplied by mg, and this one is going to the formula of frictional force. So we substitute everything in here and we'll get that kinetic coefficient of friction multiplied by the mass, acceleration due to gravity, displacement, cosine of 180 degree, plus 2g, displacement, cosine of 0 degree is equal to half. The total mass is the addition of the two masses, so this one is m1 plus m2 final speed square minus half m1 plus m2 initial speed square. Okay, let's move everything to the left, guys. Allow me to do that, and there we go. Now here, if we note, the objects start moving from 0, so the initial speed of both of them is 0. We can cancel that one. The rest of the question is just to substitute the numerical values. And we get that the answer is going to be 1,3 meters per second. This is the answer for the speed. If you solve this one, you will get the marks in the following way. 1 mark for the work energy theorem, for beginning with that one there. 1 mark for all this work up until you get at this specific point. Where am I? A little bit further. This point here will give you 1 mark. Then is 1 mark for the substitution in each case, and 1 mark for the final answer. Guys, I hope it helped. Thank you for watching. Thumb up, subscribe for the channel. I'll see you next time. Mr. G.